All right, so welcome everyone. Nice to see some old faces and new faces in the crowd. Welcome to the 20th episode of the Risk Mentorship Series. If you haven't yet, we encourage you to add your full name and your organization or country to your Zoom name so we can see who's joining us. Also, feel free to introduce yourself in the chat. Say what you love about smart water, why young professionals are important in the sector. Super excited to hear from you guys. So just a few quick updates and announcements about who we are and why we're here. So the Risk Mentorship Series is brought to you by the Smart Water Networks Forum, the leading global hub for smart water, alongside RiSWP, the Rising Smart Water Professionals, which is our young professional 35 and under affiliate. And we welcome you all here today. So just a little bit more about RiSWP and what we do. We have a couple of initiatives that we invite all of you to get involved in, and we can also share some links in the chat for you guys. So first off, we have a career development program on our website. Our RiSWP leadership team over the last couple of years has developed a really robust career portal with lots of different resources in there to help you with your smart water job search. We're also in the process of creating some smart water courses in a portal to learn more all about smart water. We already have a few different workshops included in there, so we invite you to check that out as well. Our mentorship program, that's what we're all here for today, to learn from the best in the field, from across all different parts of the smart water sector, from the ecosystem, from the engineering firms, the water utilities. We're here to answer any questions you may have. So as the episode progresses, if you have any questions, feel free to drop them in the chat, and Jade, our host, will try to incorporate them in, and maybe at the end, you can even unmute yourselves and ask those questions. And then lastly, we have our ambassador program, which is RISP's leadership initiative for early career professionals who are interested in really developing themselves as the smart water leaders of tomorrow. And speaking of our RISP ambassadors, we actually just launched our third cohort of RISP ambassadors. A couple of you are actually here in the audience. If you guys want to wave your hand, any ambassadors that are joining us, congratulations to all of you guys. We have a cohort of 14 ambassadors from all over the world. It's actually our first time that we have a full cohort from the Asia Pacific region. So it's also really nice to see so much growth within the program. And we're really looking forward to what you guys are going to do over the course of the next year. So congratulations to all of you. Also, a new feature on the SWAN website that was actually designed by one of our previous ambassadors. So this is an outstanding contribution from our last cohort's ambassador, Kedar Dibkar. Lighthouse is an AI-enabled search tool that's built into the SWAN website. So you can go in there and ask all of your pressing smart water questions and get linked to all the resources and find all the answers you need. So we encourage you to check that out. SWAN members can ask unlimited questions. It's also in its beta version. So we're happy to hear feedback from anyone that's using it. If you notice things that can be improved, we're all ears. And thank you guys so much for helping us make it better. Lastly, we have our 14th annual conference coming up in Vancouver that you're all invited to join us at. There are special discounted prices for young professionals and even heavier discounts for young professional SWAN members. We also have a couple of volunteer spaces. Volunteers would be helping us to take some notes and develop some key takeaways from the event. They'd also be able to present their key takeaways at the end of the event on stage in front of everyone. So it's a really great opportunity for exposure. All volunteers receive a complimentary pass to the conference. So if that's something that interests you, feel free to reach out after this episode. We're happy to hear from you guys. Still a few spaces left for volunteers. And with that, I'm going to hand it over to Jade Pereira, the chair of the RISP leadership team and the host of our RISP mentorship series.
Thanks, Sandy. Hi, everyone. Welcome to our 20th episode of the mentorship series. If you're interested in the previous episodes, you should check out our YouTube channel. So a little bit about what the series is about. With a set, we have a bunch of interactive digital interviews with the world's leading smart water sector professionals. So we typically have a set of guiding questions that we'll be asking Ayman about. And we'll have some time at the end for audience Q&A. But we encourage you to post all of your questions in the chat as and when it comes to your head during our talk, and then we'll try to ask it in the middle of the session as well. We want it to be super interactive. We want a lot of questions. The less I talk and the more that the audience is asking questions, the better for us, honestly. Yeah. So a little bit of an introduction about our guest today, Dr. Ayman Alafifi. Dr. Alafifi has over 11 years of consulting experience in urban water resources planning and management. He is a trained data scientist and an expert in business intelligence. He has led multiple hydraulic and hydrological modeling and planning efforts and was the technical lead for numerous large-scale decision support tools. Dr. Alafifi is experienced in leveraging advances in technology such as automation, cloud computing, and dashboards to streamline the planning and operations of complex systems, prioritize alternatives, and improve communication of modeling and planning outputs. Dr. Alafifi currently leads the technical innovation at EKI Water and Environment Consulting Firm, where he develops dashboards and decision support tools to help public and private sector clients efficiently manage their environmental data. He is an avid volleyball player and ping pong player and proud father of 4 beautiful daughters. So welcome, Dr. Ayman Alafifi, to our episode.
Thank you, Jay. Pleasure to be here.
Yeah. All right, so let's get into it. My first question really to any guest is, how did you get interested in data science and, smart water in general in your career?
Oh, okay. So it's an interesting question because it's one of those fields where you really feel like you're a beyond professional throughout your career because you continue to learn, things keep evolving really quickly, and it's one of the things that really pushes our industry forward in a way that we've never seen before. In a sense that most of the work that we've been doing as water or civil engineers for the last 100 years or even more has been mostly in traditional engineering, where we know that we study the laws of physics, we understand how to design systems, how things work, we understand the hydraulics, we understand the hydrology. Those things have been fairly well defined. There are some exceptions, there are still some innovations, there's still some research that's been done in these areas, but it's not as fast as it used to be. Now, with the advances in data science and new technologies, we're really pushing the envelope and we're doing things that we never dreamt of doing before. And that's one of the reasons why I started seeing this field early on in my career, like 15 years or more ago when I did my undergrad. I took a course in programming. I learned a little bit about an intro to artificial intelligence. That was in the early 2000s when that term data science wasn't even coined yet. And I got to play with those tools a little bit back then in MATLAB. And I really found it fascinating and interesting, not from what it can do, because back then I didn't understand really the math behind it, but it's mostly in understanding the automation part where things could be done a lot faster. And it's something that you learn how to do once, and then you become really good at it, and then you find the kind of the next challenge. And sometimes it has nothing to do with engineering. It could be just your day-to-day life in the things, how you manage your files, how you move things around, how you handle large amount of data, and even kind of planning your day-to-day like errands or shopping or stuff like that. Those were the kind of things I found really interesting early on in my career, and started looking for venues to apply those things throughout everything that I touch and everything that I do, and found this to be really, really rewarding.
Nice. Yeah. Great answer. I'm curious, you said, you've been in this field for like 15 years. How has data science changed like from 15 years ago to now? What do you think? Just about how it's changed.
So the main thing that keeps changing are really the terminology we use. So we use terminologies like smart water or digital twins or business intelligence or data analytics. More recently, we're using artificial intelligence or machine learning applications. What hasn't changed over the years is the purpose of what we're doing. So regardless of how we define it, it still all comes down to we're trying to leverage technology to do more with less. So if you think about it from that perspective, regardless of what you call it, there's always a way for you to do things a lot better, whether it's in automation, whether it's in data analytics, whether it's in data visualization or dashboards or things like that. What's become really interesting in the last year or so is with the introduction of large language models, especially with ChatGPT and programs like it, which really, in a sense, democratize this field a little bit more. So people don't necessarily need to have programming skills to do the kind of things that you can do right now with something like ChatGPT. So, and as this field continues to grow, we're going to see more and more applications of ways to try and automate our work, doing data analysis a lot better, debugging our code, or even writing code for us. So the kind of work that required people to learn coding the hard way is now a lot easier, and there's a smoother learning curve for people to be able to apply those skills to do more with technology. Those barriers were harder before because you need to come from either a computer science background or you need to take some courses in programming to be able to understand what the code is doing. And I'm not saying those are not needed anymore, because those are the foundation for what we're using. But now the learning curve is a lot easier. The barrier is a lot smaller because all it takes is some basic knowledge, some basic understanding of the technology, its applications, the risks of using it, and some guardrails. With some hand-holding, you can easily achieve a lot more now. So that's certainly something we haven't seen before, and something will continue to evolve. And the competition, obviously, in this space is fierce. So we'll see more and more of new tools that will come out that will do remarkable things. And it's a matter of how much of these tools and technologies we can apply in our industry.
Yeah, that's a great point. Like, one is there are all these buzzwords, but really what we're doing has always been the same and it continues to be, but it's getting a lot easier and constantly changing to apply all of these interesting data science tools with all of the advances in tools and technology that we have. Great.
Absolutely.
Yeah. So Ayman, I think I want to start somewhere in the beginning. Like, you're a doctor, but you're now in consulting. So what was it like? Like, you could have just gone down the academia route, but then you chose to switch into consulting at some point. So how did you make that decision, and what sorts of factors were you considering?
So for me personally, so after I did my PhD, it was focused heavily on like building optimization models for water providers and for water agencies. So it was a really fun and interesting project. What I personally, while I really enjoyed the research and the innovation part of that and trying to push the envelope in academia and in research, for me personally, working on a project for many years on just a single project wasn't uh, very satisfying, because before I did my PhD, I came from a consulting background as well. I used to work for a consultant, and one of the things I really enjoyed having is the flexibility to work on multiple projects at the same time. So while it certainly takes a toll on you in terms of kind of being able to focus or shift attention quickly between projects, it means that you have more dynamics to, like, if I'm working on a project and I'm stuck on something that I can't figure out, I can kind of switch my focus to something else, work on a different project, and that sometimes that helps uh, by just changing atmosphere or working with different people helps me kind of figure out the problem, or just taking a break from project and working on something else. With academia, and this doesn't obviously apply to everyone, but for me, working on a single research project for a long time is something that I didn't feel like I'm gonna enjoy doing for the rest of my career. So, and I also found the work that I do in consulting is, while it could be challenging at times, it also has that satisfaction of seeing an end product and being able to build something for someone, hand it off to them, make sure it works. They work with it, they give you feedback, and you get that satisfaction of whatever you built, whatever you put together is something that is being used by others, and it's helping them become more efficient and more productive. And that in itself is a satisfaction that you get a quick return on your investment in consulting. While in academia, it takes more time to see that return.
Mm-hmm. Yeah, yeah. Yeah, I guess if you want to work on like multiple things at once, like and interact more with lots of people, guess consulting or or just like not academia. But I'm sure like there are pros to academia, right? Like you get to be on the cutting edge of where like you're pushing the industry forward in terms of the science of it
Right.
all.
I agree, but with that, because I'm sure we have people in the audience here who are uh, either doing their masters or PhDs. One thing that I would recommend people do is to don't get sucked too much into one very niche part of research that you lose focus of the big picture, because that's something that I've seen over and over again with people who stay for a long time in academia. And again, that doesn't apply to everyone and every project, but if you get too focused or too detailed in one aspect of what we do and you lose sight of that big picture, sometimes you become the expert in this one thing. But if you try to switch careers and go to work in the public sector or in the private sector, sometimes you might not find that application for what you're doing. So that doesn't mean the skills won't be transferable, but it means that what you're working on might only be applicable for a very niche market, which means that if you're lucky to get a job in outside of academia in that market, then you're probably will be doing great because you're one of the few who are doing that. But if that market is really small, that could also mean there aren't that many opportunities to switch careers. So just keep that in mind.
Yeah, that's great advice, for sure. All right. So, okay. Now you've decided you're in consulting. What is the day in your life now? You're the innovation lead at your company. So what kind of work are you doing 9 to 5?
So most of what I do right now, so I come from, like you said, come from a water resources background. So I spend a good part of my life kind of building hydrologic modeling, doing the kind of work that I went to school for. Um, Now in my current position, I work on two fronts. Big part of what I do is helping our project teams work with clients on the innovation front. So let's say we're building a numerical model, a groundwater numerical model for a client. Those models typically tend to be on a larger scale. They're very computer intensive, and they're done most likely completely in a programming language, like in Python, for example, or in R. So these types of models are great for us as modelers, but for clients, they only get to see the outcome of those models. So they just see the final report of the results that they get. So a couple of projects that I've done here was to kind of bridge that gap between what the technical modelers are doing and what the clients see by building an interface that clients can use to pass new inputs to the model, run the model themselves without touching the code. It's all through an interface. So they pass new inputs to the model, hit run, they did the outputs, they're able to see the outputs and interact with it. They can save scenarios and things like that. So it's not really, we're not building a complete software. We're using open source tools and technologies that others have built when they build those models. We're just building interfaces on top of those models. Um, Other applications could be in providing ways for clients to interact with data. Say if they run many scenarios for a type of, let's say, a supply and demand analysis. They have they're forecasting some demand, they have some supply options, and they want to see what supply alternatives they need to select to meet some future demand. So typically you would go through this exercise in an Excel spreadsheet, for example, or through some workshops. So we can build a tool for clients so they can use that to directly enter data. They did the list of projects in there. They can select projects to see how many projects I need to select to meet that demand or expected demand, and what would be my deficit. If so, those are the kind of things that I do to help clients make more informed decisions, and also really bring the wow factor to what we're doing. So it's not just static reports with maps and figures, but it's all interactive. It's all linked to spatial and temporal data. The other part of what I do as well is on helping clients build efficiencies in their systems. So if they collect data from multiple sources, we sit with clients, we talk to them about how to centralize their data so it's all connected to each other. So there is some type of a data model that shows the relationships between all their data. So when they receive data from different agencies, or they send their field staff to collect data, that data is indexed or is described in a way that makes it navigable, that's searchable. You can query that data, and once you build that, you can build really anything on top of it. You can build a dashboard, you can build interactive maps, you can build a systems model or an optimization model, the kind of things that really require clients to have a solid foundation for their data collection and data analysis. So when clients try to get to the point where they're trying to digitize things, move to a framework that is similar to a digital twin, this is really the foundation of what they're looking for, is making sure that they have their ducks in a row, their data is described correctly, they don't have gaps, their outliers are well defined, the kind of things that you really need to have to be able to make informed decisions. So that's really a big part of what I do.
Yeah, something I'm getting from all the different types of projects that you just described is like, it's not like like being in the data science field in like the water sector isn't so much specifically always about like the technical analysis and like which model you're using. A lot of it is just the client has data but doesn't know what to do with it, how to structure it, like the people inside to like, understand the data. So a lot of the data scientists work in the water sector actually is to build simple tools, like help get the data organized before you go to like more complex things like digital twins and stuff like that. I mean, what's your take on the different type, like that sort of aspect in your work?
So I completely agree. I've never in my career went through a problem of working with someone who does not have enough data. There's always plenty of data. Sometimes they're collecting their own data. That's a possibility. But there's always more data than what we can do with it. And so that always becomes an issue when you're collecting a lot of data. But let's say you have, like many of the clients I work with have used Excel, which is a great tool that many people in the public sector and even the private sector still use, and I don't see us moving away from Excel anytime soon. But the problem with a tool like Excel is you collect your data, and then you have, let's say you have 3 or 4 different models that you built in Excel that do some kind of calculations. The problem with using a tool like Excel, that if you don't structure your data correctly, what you end up doing is you have your data saved in one place, then you copy, because part of that data is needed for model 1. So you put it in sheet 1 in that spreadsheet. Then you have your model 2, you copy that, you have a copy of that data in spreadsheet 2, and then you have a third copy of that data in spreadsheet 3. So what ends up happening is you have 3 redundant copies of your data that are all feeding 3 different models. So the models themselves might work perfectly for your needs. The problem is every time you have a new set of data, you're collecting new information, you want to update your input data, you're updating it in 3 different places. And if those 3 different models are run by 3 different departments, then you might run into issues where one department received the updated information, the others didn't. So that's where models in any environment, even if they're in Excel, need to have some sort of a centralized input data set. Again, it could be in Excel, it could be its own thing, but it can't be, you have to separate your input data from the model engine from your outputs. Once you kind of start thinking about this mindset, then you start thinking about what would be the right way to pass inputs to this model. Should I have them in a separate Excel file? Should I have them in a database, or should I have them in multiple CSV files, and then have some direct connections to your data? So by start thinking about it that way, separating your inputs from your outputs from the model itself, you're really finding ways to improve your day-to-day by not doing the copy pasting every time you receive information, and finding ways to kind of document the changes as they come in. Because the last thing you want is to present 2 models that were designed for different purposes, but they're using 2 different inputs because someone forgot to copy paste, or they did some manual error and pasted the values in the wrong cell or something like that. So those things happen, and they're going to continue to happen. So every time we see an issue like that, that would be the first thing that we try to tackle is, let's try and map out your data flow, where you get your data from, what do you do with that data, and where and what outputs do you generate from that data for different report purposes. Once you start building that framework, then you can start putting the pieces in their right location, and you realize that maybe you have everything in one place and you need to separate them out, or you have that information scattered everywhere and we need to centralize them. So the solution really depends on the problem that the client is facing.
Got it. Yeah. So like data set, like the type of work we're doing, a lot of it is just building processes and procedures to work with the data and like asking the right questions, it seems like. Okay,
Exactly.
Carolina Ternesi has a question she put in the chat. I don't know, Carolina, are you able to unmute yourself and ask it?
Yes, one second. Sorry, I'm in a shared working space, and they're very loud. And that person is my mom, so it's okay for me to say. Um, sorry. So I'm moving. I'll turn my camera on in a second. But my question was based on not necessarily something you've talked about yet, but kind of your role as like, I believe it was innovation lead, and how you find that like the adoption of innovation within your company is, as well as working with clients, because I find that like I've personally had the experience, but also like if you listen to experts, they say a lot of it is like the change management and getting people to want new ways of doing things or collecting data or using it. So what's been like your experience in this like generally conservative area, which is water, and if you have any tips on how to get like people more on board with different ways of doing things, specifically focusing on tech and data, because I think it's a bit of a like black box for a lot of people and how it works or what it means. And also with so I guess my second question would be kind of like building trust in data. I also find that a lot of utilities or clients maybe aren't sure that the data they're collecting is good, and therefore they don't really believe in any of what it's saying once you use it to do anything. So how is how have you approached those kind of hurdles in your work? Thanks.
Thanks, Carolina. That's a really good question. So let's start with question one. So there are two dimensions to that: internally within your organization and externally. And so internally, one of the things that uh, helped me throughout my career when I was in your position, where I I have an idea. I thought there's something that could happen that could really improve the way we present things to clients. Um, it's difficult to do something on a project when we're not scoped to do it, right? We don't want to present something to clients. We don't want to charge clients for some things that we didn't scope to begin with. So that's always a challenge. What was really helpful to me is as you're working on a project, let's say any type of traditional engineering project. So I'll give you an example. Uh, so one of the very first dashboards that I built was for when I was working for a large city, a large utility, and we were doing stormwater modeling for them, doing a stormwater master planning. And one of the things that I found as we were running a large amount of models, and we thought like we have models for the entire city, we have really large amount of data, and our scope was to present this to clients in a form of a report. At that time, I was still learning tools like Power BI, and I thought, let me try and see how I could use this the data that I now have and try and build a simple dashboard out of that. And so that's something that I had to do on my own time. I couldn't charge the client for it. I talked to my manager about it. He thought this might be a good idea, but again, because we're not scoped to do that, so we didn't really want to build a client for it. So I had to learn on my own, build it as an addition. And once we got it to a point where we think this is helpful, we use that in one of our presentations to the client. Again, nothing that the client really paid for, but instead of just showing them maps of like at that time was all the flooding locations across the city, we put it on a dashboard so they can click on different design storm events or zoom into different basins and see where those flooding locations are. So what that really did is it helped my manager, our company, and then the client and really understand the value of those tools. Once they start seeing the value, then we talked about what's the next phase of that. How can we take this to the next level? Because right now we've built something we didn't charge the client for, but now they really like it. They now want to pay for it and have a full dashboard that they could use to help the project manager from the client side communicate those results to their managers. So that was something that we started adding on to the project. And I found that to be really helpful. In all the projects that I did early on in my career, every dashboard that I built, every interactive visual or map that I built was something that it was an add-on to an existing project where the project has nothing to do with this, but I found a way to incorporate building something like this in my presentation to the client. And that in itself brought that wow factor. The client really liked it. My manager got the thank you note because he thought that was really helpful. And so slowly that started, I start seeing the tipping point between doing these kind of things as mini projects on the side of larger projects to these are becoming their own projects now. Because all of a sudden, I didn't pitch this idea to clients. I didn't go to clients and show them like, here's a dashboard that we can build for you, but they just show that they saw that this is something that we could build and it doesn't really take that much and we can do a lot more with this. So it slowly we got to that tipping point from the client side now to where they're thinking, yeah, actually maybe we want to do this for other projects too. How about we bring you to take this data or this project and try to apply it here, apply it there, and see what comes out of it. So the vast majority of the projects that I've done in my career, say like 90% of those projects were really on that small scale, where it's nothing, it's not groundbreaking. We're not building a software from scratch. It was something small, incremental improvement to an existing system that they were doing. So, and so that's an easy pill for clients to swallow when you come in with a 20, 30, $40,000 project rather than coming with a 200,000 project because you're building a whole new software for them. So keep that in mind as you're thinking through this. And then going back to internally in your company, it's always helpful to find champions for the work that you're doing. So most of these things are really championed by young professionals. I've never seen in a company that the type of kind of the improving digital capabilities within the company comes from their IT department or their CTO. There, there's always there are always great technologies out there. It's a matter of the people who are using those technologies to have that culture shift or mind shift to understand that these tools are really important and we need to bring them to our day to day. We can't have it's not just helping our bottom line, but it's also helping us as young professionals to feel valued, to feel that we're improving, to feel that we're bringing value. Because what you're gonna see as you progress in your career is the more like seasoned professionals. They really understand clients, they understand problems, they understand engineering, they can come up with solutions really quickly. What you bring to the table is your background, your skill set in technology, in tools, in data analytics. That's something that most seasoned engineers don't have that skill set, or even if they do, it's somewhat old and it's not going to be as good as yours. So that marriage between their client contacts, their understanding of the engineering principles, and your knowledge and understanding of the technical skills, the technology, the tools for the job, this is really important. And so finding the right mentor within the company, finding the right person to talk to, forming a small group of young professionals are all things that I've seen to be really fruitful in my career to help me find the right clients to talk to, find the right projects to work with. Because at the end of the day, you're not gonna be able to pitch a project like this to client yourself. You're gonna need to have your client service manager or your contact with the client come with you, have the trust that you can present this to the client and deliver on that service.
Yeah.
Yeah, thank you.
Absolutely.
Yeah, thanks, Ayman. You mentioned as young professionals, what we are bringing is like the knowledge of the tools and like the interest in working with new tools. I'm curious, like what kinds of tools do you think young professionals should be learning about for this type of career? I know you mentioned like all these different phases, like the data processing and connecting data between different parts, like visualization, the analysis. What tools would you recommend learning? And yeah, just interested in hearing your thoughts on that.
So that's a good question. So I would preface my answer by saying that tool is not the solution. You are the solution, meaning that whatever tool you come up with, whatever tool you use for the job, this has to do with a few factors that sometimes you don't have control over. So, and the reason why I'm saying that is I did this question a lot. People ask me, should I learn like Power BI or Tableau for dashboarding? Should I learn R or Python for programming? Should I learn SQL or SQL Server or MySQL or other types of database tools? And I keep telling them it's just because you learned a tool that doesn't mean you're going to be able to apply it immediately. There are factors that come into what's the right tool for the job. Sometimes you have a choice depending on what problem you're trying to solve, and there are some clear winners there. But sometimes it's out of your control because you might work with a client who doesn't want to pay for a license, or they prefer or don't want to use an open source tool, or they might have a preference for a type of technology they're using. So, and sometimes it's about compatibility with their systems. They might not want to use something that's not like Microsoft compatible, for example, or certified. So these are the kind of things that you have to keep in mind as you're picking the right tool for the job. Now, having said that, there are tools right now like Power BI, for example, that have a fairly simple learning curve. I recommend people to learn it. Tableau is another option. I personally, I've used both those tools for dashboard purposes. Uh, Power BI has the added benefit of creating a database model behind it, so you don't have to create a database for Power BI. It actually helps you learn the concepts of databases in terms of kind of building a data model, defining relationships between tables, understanding key identifiers and the different relationships and things like that. So uh, I recommend learning Power BI from the sense that it has an easy learning curve for most people. And if you come from an Excel background, Power BI should be fairly straightforward for you to use. But again, like everything else, it does have a learning curve. In terms of programming, uh, you you can go around learning either R or Python. There isn't really Python is certainly more powerful in my sense. It just in terms of what libraries it has and it supports, and the types of libraries that are more more needed for our industry, especially for types of modeling that we do. So Python would be preferable. R in my experience has a an easier learning curve. It's more user friendly and it's meant for statistical analysis and things like that. So you could certainly use R for as a kind of starting point for programming languages. And then the types of dashboards that you build, whether you're building something completely from scratch using our Shiny, which is a web application for built on R, or Python Dash, which is again another dashboard building tool, uh, versus using an off-the-shelf something already made for you like Power BI or Tableau. Again, really depends on the application. If you have your data ready and all you're doing is building some visuals on top of your data, then you might easily use Power BI or Tableau. If you're building an application, if you're building an interface on top of an existing model or a model engine, or you're trying to run an executable or something like that, then you will have to use R or Python. And uh, if you want full control over your dashboard elements and visuals, then building it from scratch make more sense. But again, it comes with a much steeper learning curve, and maintaining the web application once you're done building it is also, it could be a challenge. So again, keep that in mind as you're trying to think of what's the right tool for the job, or what should I learn first. But the basics of data science, any course online on Coursera or Udemy or even on YouTube that talks about just the principles of data science in terms of just understanding how data is structured, what are the best practices to maintain your data and use it in itself could be very helpful.
Yeah, that's awesome. Just to insert myself personally in here, I didn't know programming. I didn't know a lot of these things, but I knew Excel. I was working in Excel. And Power BI was definitely like a gateway for me, just to like the whole world of like, you can go out and seek tools to help. Like you yourself know you're doing repetitive things, like it's not as efficient. I wish Excel did this, I wish it did that. And that like forced me to go like find these different tools out there. And Power BI was like so simple. And I was like, oh my gosh, like what else is out there? So yeah, great point about tools. At this point, I wanna just tell the audience, please, whatever questions you have, post them in the chat, and then you get to ask them right here, or I can ask them if like, if you have mic issues and stuff. I am gonna ask at this point a question that someone in the audience actually asked beforehand. I don't know. Is Russell Perry on the out here? Let me check. He is not, but he might listen to this later on because we're going to post all of these on YouTube. So Russell Perry from Alameda County asks a technology-related question. He asks, Alameda County Water District has struggled with transitioning to cloud-based technologies, largely from discomfort with the idea of data being offsite and the large barrier of moving siloed data out of legacy systems. So I guess the questions in these are, one, could you just talk more about how, cloud-based technologies work in the data science field and in the water field? And then two, like any advice on overcoming those concerns, like the discomfort with the idea of data being offsite and the data being siloed already in these different legacy systems?
Yeah, very good question. So cloud services are really an augmentation of the compute power that we have. So when you sign up to a cloud machine, you start what's called a compute instance, and it really allows you to access pretty much an unlimited, well, relatively speaking, compute power to run anything. So it's very much been used by by many local governments, by the federal government. It's used to host large amount of data. So the concerns about moving data into the cloud is a very valid concern, and it's certainly something that's been thought about and addressed over and over by the kind of the large cloud providers. So whether it's Google Cloud or Amazon or Microsoft Azure or even Oracle, they all have their own ways of kind of trying to mitigate the kind of risks of moving data to the cloud. They all have some type of enhanced security measures. The data is encrypted. It has some duplication, which allows you to, or replication. So your data is stored in multiple locations, which means it's highly available, and they have really extensive backups. So in case of disasters, in case of data loss, in case of even hacking, the data will continue to be available. And the way they measure that is by having your data available. Then they call it, I don't know how many nines they're at right now, but they keep improving that. So there's like 7 or 10 nines. So 99.99999% of the time, your data will be always available. And the benefit, one of the biggest benefit of moving to the cloud is scalability. Meaning, like if you're the kind of agency that has needs for like really high compute or need to run high intensive models, but you only do that like once a year. You have this like really sophisticated numerical model or hydrological model that you run, and it takes few days to run. And sometimes you need to run it for multiple iterations. That's where that cloud become really useful, because you can have a compute instance or compute power that's reasonable for your needs throughout the year, but then you can scale it up for a few days and then scale it back down. So now, having said that, and then also most of these providers also have some, they have regulation and compliance issues that they have to make sure that they follow. So in terms of their security, they're they claim to be more secure than having your data on premise in terms of they're investing heavily in making sure that your data is encrypted enough that even if their systems are hacked, your data will still be protected. So that's in terms of the security part. Now, one of the things that you can also do is some of those providers like Amazon AWS, they provide something they call an on-premise or a hybrid system, and they call it AWS Outposts. So if you're the kind of agency that would like to explore an option but would like to have your data close to home where you have the full capability of AWS infrastructure, but it's hosted locally and you have full control over it, you can do that. That's something that's available. Uh, if you're if you use Esri, for example, the ArcGIS company, they have a similar offering where they can host your data for you on their Esri ArcGIS Online. They can host it on the cloud, or they can provide you with an on-premise version of their cloud. So it's not open, it's not publicly available to anyone, and you have full control over it, but it's all contained within your organization, within your VPN, for example. So that's an option if you're concerned about kind of data privacy or security. One of those companies, I'm sure, will have an option for you to have that data run more locally.
Nice. Yeah, thanks for the overview, Ayman. We're probably gonna have at some point like a whole episode on cloud technology, just like because it's a new field and yeah, what are the different applications and things to think about? So stay tuned for that, everyone, in a future episode. Christina Popa has a good question. Is she? Yeah, she's on. Christina, do you want to unmute yourself and ask the question? Okay. I don't know if you're trying to speak, Christina, but we're not hearing anything. Okay. All right. I'll go ahead and ask your question. Thanks for sharing it in the chat. So Christina asks, could you share any suggestions on how to present tools internally to colleagues who are not that tech inclined? I'm not referring only to presenting results, but also for QA, QC purposes.
So it's a good question, Christine, and kind of ties into what Carolina was asking about. So to present things internally, one thing that you can certainly do is think through if you have some type of application or a model, you run your results and you're ready to present them to your sorry, to your supervisor or your manager for QA/QC. That would be a great venue for you to think through. Like if you're in their shoes and you're reviewing that data, what would be an easy format for them to review? So let's say you have, again, to use a hydrologic model as an example, or a hydraulic model. Let's say you have 5 different design storms, you run them through your system, you identify deficiencies, you have a large Excel file where they have multiple sheets, you have to go through them and QC every sheet. They normally do that by creating some plots to see if there are any, like, are there any gaps in your results? Are there any issues you need to address, or things that don't make sense? What if you build some of those even directly in your Excel in a way where, let's say you have one visual in your Excel that shows, let's say, your time series, and they can switch the time series by clicking on different like radio buttons that show like design storm 1, design storm 2, design storm 3. And by clicking on it, that graph changes, or you can create a checkbox to add them. Those are simple things that you can add to your results that will immediately show the value of your skill set to your managers and to the person who's doing the QA/QC, in a sense that it shows that you're making their lives easier by being able to showing how quickly you're allowing them to view and slice and dice through your results without having to go through multiple sheets in your Excel file. And at the same time, you're really showing off your skills. You're bragging about how good you are, and that in itself could be something that they might like and include into your presentation to their client. And again, that could be you're probably still going to do that report to the client. You're probably going to have to generate that result 4 or 5 times. But when you present it to the client, why not show it interactively? That in itself is something that clients might really like, and might again bring that wow factor that they might take this to the next level and say like, hey, next time you present, I want you to do this for me. Same thing if you're and I did this for a client one time where we have we were doing data collection, we had sites on a map, and instead of just showing like here are the results next to our maps, why not just put it on an interactive map where you're walking through the map, you're clicking on, could be manholes or pipelines, and the results, your graphs show up immediately on top of your map. That's something that you can easily build with ArcGIS Online. It doesn't take more than an hour or two of your time to build. But again, that in itself could be a deliverable that the client hasn't scoped with you, but could easily ask you to amend your contract and add it because they might like it. They might want to have it available for them to present to their managers or put it on their website for public communication.
Nice. Oh, we have just 3 minutes left. I have one last question. Maybe you can give like a quick response for everyone. The question is, how do you like learn about new tools? You know, things are constantly changing. Where are you learning about all this stuff?
Oh, so that's a good question. So it's really hard to keep up with everything that's happening in this industry. Things keep changing really quickly. I find LinkedIn to be really useful. People normally post about new tools, new technologies they discover, or they're kind of tinkling with to see how helpful that is. So I follow a few people on LinkedIn and they post things. I post things as well. So look for those kind of individuals and follow them. Twitter is another, or X now, is another platform that people also use. If you tune out all the politics in there, you will find some good things where people talk about advances in this field, and just being up to speed with what's happening in the technology. If you're like an Esri user or a Power BI user, all those have kind of community hubs or community forums that people use, kind of almost like a Stack Overflow, but specific to that platform. So I found that to be very helpful, where people ask questions or interact with each other's. And I often post things there to get feedback from people, or to brag about something that I did and took me, like I spent my whole weekend trying to do that and it worked. So I want to get some praise from someone. And if people in my company don't appreciate it, I want to have the community see it. So the kind of things that you're learning and you're sharing with others are really rewarding and something that you learn with. So I'll show you actually a quick example of something that I didn't know how to do. I collaborated with others on and found it to be really fruitful. So let me share my screen really quickly in the last few minutes that we have. So I was building something like this for a client, where it was a simple kind of supply and demand analysis, where we had some expected demands for kind of a 3-phase project. We have a long list of like supply projects that they were trying to use to meet that expected demand. And I was trying to find the best way to make this interactive. And so after some iteration and back and forth with the kind of the Power BI community, I came up with this tool that is really designed to do that. So this is Power BI for those who haven't seen it before. And it's a way to, for me, it was a way to kind of take what's in Excel, build it completely here. So I have all like I have the 3 phases here. I have the residential, the commercial, agriculture, etc. And I can change these numbers, and the graphs on the left will immediately update on both kind of the potable and the non-potable side. So if things change, I can easily change that, and it updates the numbers for me. So that was somewhat challenging to do on the demand side, because I wanted to kind of create this kind of data entry that's not in Excel and it's not completely in Power BI. So that was kind of the sweet spot between the two. And then on the supply side, they had all kind of the list of all my projects there. And I was doing like, here are the 3 phases. The blue bars are the expected demand. And now I need to add projects here to kind of see, oh, sorry, the gray bars are the demand and the blue bars are the supply. So this is kind of an additive for how many projects I need to do to meet the expected demand. and I have it for kind of different types of kind of hydrologic conditions for dry, normal, and wet years, and etc. And so that the kind of things that you can really do with a platform like this is really remarkable. It's simple enough to do. Something like this didn't take more than a day to put together, but it did bring again that wow factor when we present this to clients. They really liked it. Think through how exactly would you do this if you're trying to do this in Excel, where you're trying to do a simple balance, but nothing really is. You can do this interactively in an interface like Excel. So Power BI was a good alternative to try and doing that.
Yeah, awesome. Thank you for sharing. I think it's a great way to end it with an example of what someone else can build. Yeah, so I hope this inspired some of you on the call to actually go out and try to build a dashboard yourself. Great. Yeah. Thank you, Ayman, for talking to us. Really appreciate it. And thank you, everyone, for joining.
Yeah, absolutely. It's been a pleasure. Thanks for hosting me. And if people want to get hold of me, feel free to share my email or LinkedIn on the email blast, and happy to answer questions if people want to know where to start or what might be the good resources. We didn't get to talk about some of those today, but happy to follow up with folks afterwards.
Great.
Thank you so much. Have a great day, everyone. Nice to see everyone.
All right. Bye.
Bye.